Hello, welcome to this channel. Here the stories are slow, long and calm. Before we begin, take this moment while you are still awake to subscribe and like this video. In a few minutes, your mind will be traveling through the steady rhythm of space, where time itself begins to stretch. Now simply settle in, close your eyes, breathe slowly, and let us begin tonight's quiet story. Good night. The night on Earth feels familiar. A second passes, then another. The movement of a clock marks the pattern, regular and predictable like footsteps on a long road. Yet what feels simple here is not the same everywhere. Time, which seems to flow evenly, does not move at the same pace across the universe. Its rhythm bends, slows and stretches, guided by the forces that shape everything we know. The weight of a second changes depending on where it exists. To understand this, imagine standing still beneath the quiet sky. Around you the air cools, the sounds fade, and the seconds feel ordinary. But above, far beyond the thin layer of atmosphere, the same second unfolds differently. On a mountain top, where gravity's pull is slightly weaker, time passes a little faster than at sea level. The difference is invisible to the senses, yet it exists. The world's clocks tick with mathematical precision, but gravity adjusts their pace, marking the subtle shift in how long each second lasts. This variation does not disturb the balance of nature. It is part of its harmony. Planets orbit because time and gravity are linked. Space curves and time follows the curve. The second you feel on Earth's surface has a specific weight, determined by the mass of the planet beneath your feet. The closer you are to its center, the more gravity presses, and the slower time becomes. The farther you drift from that pull, the lighter each second feels, as though the universe itself were loosening its hold. Scientists have measured this difference with great care. They have placed precise clocks in aircraft and satellites, sending them into orbit and watching their rhythm change. High above the Earth, where gravity's grasp is weaker, the clocks run just a little faster. Down below, the same instruments tick more slowly. The numbers are small, measured in billionths of a second, yet they reveal the quiet truth. Time has weight, and that weight shifts with position and motion. In space, away from planets and stars, seconds expand like ripples on still water. Each one stretches slightly longer, moving with less resistance. The difference is not something the human body can feel, but the universe registers it with precision. Every particle, every wave of light, moves according to time's local rhythm. It is not one single current flowing everywhere, but a field of currents, each guided by gravity's invisible hand. To sense this idea, think not of time as a line, but as a texture. It surrounds everything, soft and flexible, responding to mass and movement. When you stand still, time feels consistent, but when you move or change your position in space, that texture shifts slightly. It is the same with the planets, the same with the stars. Their immense gravity stretches the seconds around them, slowing the passage of time in the regions closest to their centers. The universe is not careless. It balances every difference with perfect precision. The weight of a second may be invisible, but its presence touches everything. The light from the sun takes about 8 minutes to reach Earth, yet those 8 minutes are not identical everywhere along its path. Near the sun, time moves more slowly. Far from it, time moves a little faster. The photons that travel between those two regions experience a smooth transition. crossing through varying densities of time itself. What we call a minute, or an hour, or a year, is not fixed in the structure of the cosmos. It is local, dependent on where and how we exist within the fabric of space. When thought slows, this concept becomes easier to feel. Every breath, every heartbeat, every small movement follows time's invisible rhythm. On Earth, that rhythm feels stable, predictable. In space it changes, but not abruptly. It bends and adjusts with gravity's field, creating a quiet continuum that links every point in the universe. There is no sharp boundary, no break, only gradual variation, a smooth blending between one flow of time and another. This is the weight of a second. It is both constant and changing, both personal and universal. On the surface of Earth, in orbit around it, or far beyond the reach of its pull, time remains the same phenomenon, yet its pace adjusts to the landscape of gravity and motion. Each second carries the imprint of where it was measured, how much mass surrounded it, and how fast it was moving. The result is a universe where time is not rigid, but alive, not emotional, not conscious, but responsive to the conditions that shape it. As your breathing deepens, you may notice your awareness slowing in the same way. The seconds of thought begin to lengthen. The rhythm of the story matches the calm expansion of your own perception. Time, even here, bends slightly with attention. The quieter the mind becomes, the slower each moment feels. In this way, you experience what the universe has always known. Time changes with motion, with mass, and with stillness, the gentle mechanics of time. Time can be approached without mystery when it is treated as the quiet record of change, the steady ordering of one state after another, the background against which motion and rest can be described with clarity. In daily life, time is sensed as the rhythm of breath, the pattern of daylight and darkness, the regularity of a heartbeat, and the slow shifting of shadows on a wall. Yet beneath these familiar patterns lies a simple fact. Time is the parameter that allows the universe to compare before and after, to count the intervals between events, and to keep the sequence of causes and effects in a reliable order that does not need to be dramatic to be true. Physicists work with this idea in a way that remains calm and exact. They select processes that repeat with remarkable stability and let those processes serve as standards. A pendulum under uniform conditions, a crystal vibrating in a controlled field, or a cloud of atoms switching gently between energy states can mark intervals that are consistent enough to be trusted. Among these processes, certain atoms provide the most reliable reference because their internal transitions occur with a regularity that does not depend on weather, on mood, or on expectation. When such a transition is used to define a second, the definition is not poetic. It is a practical statement that one can return to, that one can test, and that one can share. From this simple grounding, time extends outward into the wider structure of the universe. Motion is described by how positions change with time, energy by how systems transform across time, and temperature by how energy distributes through time toward balance. Even entropy, which is the careful measure of how many ways a system can be arranged, gains its meaning from time, because it tells us which arrangements are most likely to appear as the moments proceed. In this way, time is not a separate thing sitting outside matter and light. It is the smooth parameter, woven into every description of their behavior, always present, always steady, always measurable through change. The next gentle step is to notice that the measurement of time depends on where and how it is measured. Each observer carries a personal clock, whether that clock is an instrument in a spacecraft or the quiet rhythm of a pulse at rest, and each clock follows its own path through the geometry of the universe. Along that path, a quantity called proper time records the interval actually lived by that clock, and proper time can differ from the intervals recorded by other clocks moving differently or resting in different gravitational fields. This difference does not break the unity of physics. It expresses it, because the laws that govern matter and light ensure that every properly measured interval remains consistent within its own path, while relating predictably to all the others. Space-time, a single fabric that includes both distance and duration, gives a simple framework for these observations. When mass is present, the geometry adjusts, and when motion is present, the comparison between paths changes. Because geometry and motion are linked, two observers can meet, compare clocks, and agree on the difference without confusion. The one who remained deeper in a gravitational field will have experienced slightly less time, and the one who moved swiftly relative to the other will have experienced slightly less time as well. And the amount of difference can be calculated from the same quiet equations that guide the paths of planets and the bending of light. Instruments confirm these statements with patient repetition. Clocks placed on a tall mountain gain a small advantage over clocks kept near sea level, not by opinion, but because gravity is weaker higher up. Clocks carried on fast aircraft or orbiting satellites accumulate time at rates that diverge gently from their companions on the ground, and the differences, though small, follow the predicted values with dependable accuracy. This is not a matter of belief. It is a matter of measurement that can be verified as often as needed, and it is why systems that guide navigation adjust their internal timing to remain aligned with reality. When the mechanics are viewed with calm attention, a simple picture emerges. Time is the consistent ordering of change, marked by processes that repeat, compared between observers who move differently or rest at different heights in a gravitational field, and unified by a geometry that treats distance and duration as parts of one structure. There is no need for images of stretching or tearing. There is only a precise relation stating that mass curves the paths we follow, and that speed alters the rate at which our clocks advance, all within rules that have been tested in laboratories, in the atmosphere, and in space. For the listener settling into rest, this picture can be allowed to slow the mind. The pulse is a clock. The breath is a clock. The growth of a shadow is a clock. Each one is a local measure of change, and each one can drift slightly relative to distant standards without losing its meaning. The universe accommodates these differences with ease. It does not insist that every second be identical everywhere. It allows every path to carry its own steady record, while preserving the simple order of cause preceding effect along each path. In this way, the gentle mechanics of time invite a kind of quiet trust. The world remains coherent because the rules are both flexible and exact. Seconds are defined by stable processes, intervals are lived along personal paths, and comparisons are guided by equations that do not fail. When these ideas are spoken in a soft voice and considered at an unhurried pace, they reduce mental friction. They suggest that there is room to rest within the structure of reality, that the unfolding of moments can be observed without tension, and that understanding can arrive without pressure, one measured interval after another, as steady as a calm breath moving in and out. The gravity of seconds. The passage of time is not uniform. It bends gently under the influence of gravity, following the same rules that govern the motion of light, the orbit of planets, and the structure of space itself. This bending is not abrupt, nor does it disrupt the balance of nature. It is a quiet and measurable shift, one that has been confirmed through observation and experiment many times. Each clock in the universe moves at its own pace, and that pace depends on how deeply the clock rests within a gravitational field. Gravity, as it is known in modern physics, is not a force pulling downward. It is the natural curvature of space-time caused by mass and energy. Where there is mass, space bends inward and time slows in response. The stronger the gravity, the slower the passage of seconds. This relationship, though invisible, shapes the world in steady and predictable ways. On Earth, time runs fractionally slower at the surface than it does on the top of a high mountain. The difference is small, measurable only with precise instruments, but it exists. Even this planet, quiet in its orbit, reveals the truth that every point in space experiences time according to its position in gravity's field. In a calm laboratory, atomic clocks rest as instruments of precision. When one is raised several meters above another, their rhythms begin to diverge. The higher clock, experiencing weaker gravity, ticks slightly faster. The lower clock, held closer to Earth's mass, ticks slower. This experiment has been repeated with satellites orbiting far above the surface, where gravity's hold is weaker still. The results remain consistent. The same second, defined by the same physical process, lengthens or shortens depending on location. Gravity gives each place in the universe its own version of time, not through disorder, but through balance. This effect extends far beyond the boundaries of Earth. Near massive stars, time slows in a way that can be calculated precisely. The closer one moves to the star's dense surface, the greater the curvature of space-time, and the more each second stretches. For an observer at a safe distance, the light from near the surface appears slightly redder, its wavelength stretched as it escapes gravity's grasp. The change in color is not a sign of struggle or escape, but of time itself flowing differently near the source of gravity. What happens there is not chaos, but the calm unfolding of a universal law. In the case of extreme gravity, such as near a neutron star or the outer boundary of a black hole, the slowing of time becomes profound. For a distant observer, an object falling toward such a region appears to move slower and slower, as if caught in a frame that never ends. From the object's own perspective, however, time continues smoothly. Both experiences are correct, each one describing time from within its own region of gravity. The universe allows both to exist without contradiction. It is this consistency that makes relativity a science of calm precision rather than mystery. Gravity does not simply affect matter, it guides the tempo of existence. Every atom, every photon, every living cell experiences the world according to the local rhythm set by the gravitational field it inhabits. This relationship gives structure to galaxies, stability to stars, and balance to the orbit of planets. Without it, time would not unfold in a coherent order. It would drift apart, unanchored. Instead, the universe moves with quiet regularity, every second adjusted to the curvature around mass. every pulse synchronized by the geometry of space-time. When thought slows enough to follow this idea, it becomes clear that time and gravity are inseparable. The pull that keeps the body grounded also shapes the rate at which its moments pass. A person living at the top of a tall building ages ever so slightly faster than someone living at the ground level, though the difference is immeasurable in daily life. In the same way, the satellites that orbit high above Earth experience time at a subtly faster pace, and their clocks must be adjusted so that signals sent to the surface remain accurate. Navigation systems depend on this quiet truth, proving that even our most practical technologies must acknowledge the softness of gravity's influence on time. To think of gravity is often to imagine weight, but in physics, it is not heaviness that matters. It is curvature, a bending of the fabric of reality that slows the motion of everything within it, including time itself. The Earth bends space-time gently. The sun bends it more. Black holes bend it completely. Yet across all of these scales, the rule remains the same. Where gravity is strong, seconds stretch. Where it is weak, they pass more freely. It is a continuum, smooth and exact, connecting the smallest particle to the largest galaxy. As you breathe slowly, imagine yourself resting in this structure. Gravity holds you in place, anchoring your body, while time moves through you at the pace set by the planet beneath. The air, the ground, the distant stars, all part of one field, each region marking its own slow rhythm. The pulse in your body is another clock, a soft echo of the cosmic order. It follows gravity's curve without awareness, obeying the same rule that governs the stars. The gravity of seconds is not a burden, it is a pattern of precision. It links all matter through the simplest of relationships, that time, like light, bends with space. This principle, first discovered through observation and confirmed through countless measurements, describes a universe that is both dynamic and calm, where even the weight of a moment is shaped by position in an invisible field. Time, therefore, is not only movement, but depth. Every second carries the impression of gravity's pull, quiet and continuous, adjusting the pace of existence with unwavering accuracy. The curved fabric of stillness. The space surrounding every object, every planet, every star is not empty. It has form, though it cannot be touched. It stretches and bends, shaping the path of matter and light. This form is known as space-time, a single continuous fabric that holds both distance and duration, both where something is and when it exists. The curvature of this fabric is not visible to the eyes, but it can be measured by its effects. It gives gravity its meaning, it gives orbits their precision, and it gives time its variable rhythm. The universe does not rest on a rigid structure. It rests on one that flows and adjusts without pause. Imagine space-time as the calm surface of a lake seen from far above. It appears still, but every object that carries mass creates a quiet indentation in that surface. The more mass it has, the deeper the curve becomes. Yet unlike water, space-time does not move or ripple in waves that can be seen. Its curvature is steady, a permanent record of how mass tells space how to bend, and how space tells matter how to move. Every planet, every star, every galaxy leaves its own smooth impression, and within those impressions, time itself slows. When Einstein described this relationship, he did not use metaphors of stretching or strain. He wrote of geometry, of shapes, of paths, of intervals that remain consistent when measured along curved lines. The equations that describe this geometry are calm and precise. They state that where there is energy or mass, the geometry of space-time must curve, and that all motion, even the motion of light, follows the natural lines drawn by that curvature. Time is one of these lines. It bends alongside space, adjusting its pace to remain in harmony with the shape of the universe. This concept replaces the old view of gravity as a force pulling downward. There is no rope, no invisible thread. There is only the quiet path of least resistance through curved geometry. When a planet orbits a star, it is not being pulled in circles. It is following the straightest possible path in a curved environment. The same principle governs the fall of an apple, the orbit of the moon, and the slow movement of distant galaxies. The shapes may differ, but the rule remains. Motion is geometry expressed through time. The stillness of space-time is what makes this system stable. The curvature does not fluctuate wildly. It adjusts gently, responding to mass and energy in proportion. When a star forms, space-time deepens around it. When a star fades, the curvature softens. These changes are not dramatic. They occur gradually, maintaining balance across vast distances. Every particle contributes to this balance, even the smallest amount of energy, leaving a faint but measurable mark. In this way, space-time is not a background upon which things happen. It is the quiet stage that is itself shaped by the performance. If we could perceive time in the same way we perceive distance, we would see that the universe is not a collection of separate moments, but a continuous surface, smooth and uninterrupted. What we call the present is simply the location where our consciousness touches that surface. As the body moves, as the planet spins, that contact shifts along the fabric, tracing a line through space-time called a world line. Every object has one, from the smallest atom to the largest star. Each world line marks the history of motion and rest, woven into the same continuous structure. The bending of this structure has consequences that extend far beyond intuition. Near a massive planet, the geometry curves inward, and the world lines of nearby objects bend toward its center. Time slows slightly in this region, not because something interferes with it, but because the path of time itself has lengthened through the curvature. In the emptiness between galaxies where gravity is faint, time runs more freely and seconds stretch wider. These differences are small when measured locally, but immense when measured across cosmic distances. The entire universe, therefore, is not ticking in unison. Each region holds its own rhythm, all connected by the same geometry, all following the same laws. There is no resistance in this system. Space does not fight its curvature. Time does not struggle against gravity. The universe accepts the shape of its own structure without friction or hesitation. This acceptance creates stillness, not the stillness of emptiness, but of balance. Everything that moves through space-time does so because the geometry allows it, and everything that rests does so because the curvature supports it. The black hole, the orbiting moon, the drifting dust, all are expressions of the same quiet principle. As the listener settles deeper into calm awareness, this idea begins to feel natural. The breath continues at a slow pace, the pulse remains steady, and thought begins to move in long, even lines. The body rests in the curvature of Earth's gravity, and within that field, time moves according to the same soft rules that govern galaxies. There is no need to imagine the fabric stretching or the stars shifting. The geometry is already perfect in its motionless precision. This is the curved fabric of stillness. It connects every corner of the universe through an invisible network of balance. It defines how moments follow one another and how movement finds direction. It is both the reason gravity exists and the reason it feels so calm. Every breath, every orbit, every rotation takes place within this structure. Time does not simply pass through it, it is part of it, shaped by it, and inseparable from its quiet design. The slow dance of speed. Motion, like gravity, changes the rhythm of time. When something moves quickly through space, time for that object slows in proportion to its speed. This principle, known as time dilation, is not a matter of perception but of geometry. It is a calm and measurable effect, discovered through experiment and confirmed with precision. The faster an object travels, the slower its clock runs compared to one that remains still. Yet the difference is not dramatic. It is quiet, continuous, and perfectly predictable, an unhurried dance between movement and time. At rest, a clock measures the steady flow of seconds in its local field of gravity. But as the clock begins to move, its experience of time changes. From its own perspective, nothing feels different. Its internal rhythm continues normally. However, to an observer watching from a slower frame, that clock appears to tick more gently, each second stretched slightly longer. Both viewpoints are correct. The clock has not malfunctioned, and the observer has not imagined the effect. They are simply seeing time from two different paths through space-time, each valid in its own measure. This behavior is described by the theory of relativity, where space and time are bound together so tightly that a change in one requires a change in the other. When an object moves faster, part of its motion through space comes at the cost of its motion through time. It covers more distance, but its internal seconds slow down. The total motion through space-time remains constant, balanced like the sides of a quiet equation. No energy is lost, no rules are broken. The universe allows this exchange to maintain harmony between movement and duration. At ordinary speeds, such as a person walking or an airplane crossing the sky, this slowing is far too small to notice. It becomes meaningful only as speed approaches that of light. At such high velocities, the flow of time stretches noticeably. For a spacecraft moving close to the speed of light, a journey that seems to take only a few years on board may correspond to decades passing for observers at rest. Yet even then, to the traveler, the trip feels natural and unchanging. Time always feels normal from within one's own frame of reference. It is only when compared with others that the difference becomes clear. This difference has been measured with care. In experiments, subatomic particles moving near the speed of light live longer than identical particles at rest. Their internal processes slow, extending their existence. In laboratories, scientists observe this consistently. The effect is not subtle when speeds are high enough. It demonstrates that motion is not just a change of place, but a change in the way time itself is experienced. The universe does not punish speed. It accommodates it through balance, slowing time to preserve consistency in every observation. The relationship between speed and time can also be seen in the journey of light itself. Light moves at the ultimate speed allowed by nature, and in doing so, it experiences no passage of time at all. From the photon's perspective, the beginning and end of its journey are the same event. It leaves a star and arrives at an eye or a sensor, crossing space in what, for it, is no duration. For everything else, the trip takes time. But for light, time stands still. This comparison, though abstract, reveals something fundamental, that time and motion are threads of one fabric, each defining the other through perfect symmetry. In the calm structure of the cosmos, this slowing of time keeps all motion coherent. It ensures that energy, mass, and information remain connected across frames of reference. Without this adjustment, the laws of physics would break, but because of it, they remain whole. The planets continue their orbits, the stars emit their light, and the galaxies drift apart according to the same constant principles. Time dilation is not an exception. It is a quiet expression of the universe's logic, a smooth correction that keeps reality aligned across every scale. For the human mind, this concept can become an experience rather than a calculation. As the body grows still and awareness slows, perception of time changes too. The seconds stretch, and each breath feels longer. This effect, though psychological, follows the same pattern as the cosmic rule. Movement and time are connected. When physical or mental motion slows, time seems to expand. When activity increases, time contracts, rushing past unnoticed. Both scales, the physical and the experiential, follow the same universal rhythm. The quieter the system, the slower its time. To imagine this principle, one can picture a spacecraft drifting silently through space. It moves at high speed, yet within its cabin, everything feels calm. The clocks tick softly, the instruments glow steadily. The traveler's heartbeat remains slow and regular. Outside, distant stars slide past in quiet arcs. Inside, time unfolds at its own measured pace, unhurried and consistent. Far away, observers see the ship's clock running slower, but for the traveler, each moment feels the same. This contrast between views does not create confusion. It creates unity. The two perspectives are part of one equation, one truth. This is the slow dance of speed, the gentle trade between motion and time that keeps the universe balanced. Every movement, from the smallest particle to the fastest jet, follows it. Each second adjusts itself to match velocity, ensuring that the total flow of reality remains even. It is not a dance of excitement or chaos, but one of still coordination. The universe expands, stars orbit and atoms vibrate, each moving at its pace through space-time, each adjusting its seconds to stay in quiet synchrony with all the rest. The clock in orbit. High above the surface of the Earth, where gravity's pull grows faint and air no longer resists motion, time flows at a slightly different pace. It does not race forward or leap ahead. It simply moves a little faster than it does on the ground. The difference is small but measurable, and its discovery has shaped the way the modern world keeps track of its moments. The clocks that orbit the planet, circling at thousands of kilometers per hour, confirm this every day. They reveal, quietly and consistently, that time is not universal. It depends on both speed and gravity, acting together in the same smooth balance that governs all of space. Each satellite carries a set of atomic clocks, instruments built to measure time with precision so high that even a billionth of a second can be recorded. On the surface of the Earth, identical clocks follow the planet's slower rhythm, held slightly back by gravity's weight. But in orbit, where the pull is weaker, the same atomic transitions occur a little faster. Motion adds a second layer of influence. The satellite's speed slows time slightly, while the lower gravity allows it to move ahead. The two effects work in opposite directions, and when combined, they leave the orbital clock running just a bit faster than its twin on Earth. This difference might seem unimportant, only a few microseconds per day, but when those microseconds accumulate, they reshape how navigation and communication systems function. The signals from these satellites guide travelers across oceans, pilots through clouds, and spacecraft through interplanetary space. If the small shift in time were ignored, the coordinates would drift by kilometers within a single day. The accuracy of global positioning depends on recognizing and correcting this quiet truth of relativity. The engineers who built these systems did not change physics to make them work. They accepted physics as it is, precise, predictable, and curved by gravity. When the satellites were first launched, scientists already understood the need for adjustment. The onboard clocks were set to tick slightly slower before they left the ground, so that once they reached orbit, they would align with the slower pace of Earth-bound time. The correction worked exactly as predicted. Each clock, moving through its own path in space-time, recorded intervals consistent with its local field. When compared across distances, the differences matched the calculations of relativity with perfect accuracy. There was no surprise, no conflict, only confirmation that the universe keeps its rules, even when humans take their instruments beyond the atmosphere. The experiment continues every moment. The network of satellites orbiting Earth acts as a permanent laboratory for understanding time. They drift in their paths with steady precision, each one sending pulses of information that include its position and the count of its internal clock. Receivers on the ground use these signals to calculate location by comparing the arrival times from several satellites. In this process, relativity is not a correction added afterward. It is part of the design. The system works because the engineers accounted for the way time bends, stretches, and slows in motion and gravity. The world measures itself through the fabric of space-time without even noticing. This quiet example shows how theory and observation converge. The same equations that describe the motion of galaxies also describe the operation of satellites and clocks. The difference in scale does not matter. The principle holds from the smallest particle to the largest structure. Time is not uniform. It follows geometry. The satellites, though built by human hands, have become instruments that reveal this geometry in real time. Their steady pulses are like heartbeats of the planet, each one marking a second shaped by both the Earth's pull and the freedom of orbit. From a calm viewpoint, the system becomes a symbol of balance. The ground and the sky exchange time constantly, their rhythms kept in harmony through correction and understanding. Gravity slows one clock, motion slows another, yet both remain consistent within their own paths. The mathematics connecting them is exact. It ensures that messages reach their destinations, that maps align with the terrain, and that every moment across the planet can be measured against a single, quiet standard. What seems complex is simply the universe following its own design, indifferent to scale, perfect in its continuity. The image of a clock in orbit can serve as a reminder of how fragile yet stable our perception of time is. On the surface, time feels absolute, a steady current that carries everyone at the same rate. But above, in the emptiness of orbit, the same seconds expand slightly. The difference is small but real, showing that the universe allows variation while maintaining order. It does not require uniformity to remain consistent. It only requires that every part follows the same laws no matter where it is. If one could float alongside a satellite, watching the curve of the Earth below, time would appear still and endless. The blue of the planet would pass slowly beneath, clouds forming and dissolving in silence. The sun would rise and set many times within a single day, yet the rhythm would remain smooth and predictable. Each orbit would mark the repetition of time's pattern, a closed loop of gravity, motion, and precision, all unfolding at a measured pace. The satellite does not know it is moving faster in time than the ground below, just as the ground does not feel it is slower. Each follows its own quiet clock, synchronized by the geometry of space-time itself. This is the clock in orbit, a silent teacher showing that time is not a single stream, but a field shaped by motion and gravity. It runs at different speeds in different places, yet it never loses coherence. The universe keeps perfect time not through uniformity, but through adjustment. Each orbit, each rotation, each pulse of data from space carries proof of this harmony. Every second measured above reminds the world below that time, even when divided, remains whole. The human perception of time. Beyond the mathematics of relativity and the precision of atomic clocks, there exists another form of time, the one that unfolds inside the human mind. It is not measured in absolute seconds or defined by gravitational fields. It is fluid, variable, and deeply connected to awareness. The perception of time expands or contracts according to attention, emotion, and stillness. While physics describes the external structure of time, perception reveals its inner experience. Together, they form a quiet parallel. The physical world shapes the tempo of clocks, while consciousness shapes the tempo of thought. When the mind is active, time seems to move quickly. Hours vanish in the rhythm of tasks and conversations. The brain measures change through events, and when many changes occur, time feels compressed. Yet when activity slows, during waiting, observation, or rest, the mind counts fewer events. The seconds feel longer, stretched like calm waves on a still lake. This difference does not mean that the physical pace of time has changed. It means that awareness, functioning as an internal clock, has adjusted its resolution. Just as gravity alters time's rhythm near massive bodies, stillness alters its rhythm within the mind. Physiologists have studied this perception carefully. They have found that neural activity, body temperature, and heart rate all influence how moments are experienced. A slower heartbeat often corresponds to a slower sense of time. When breathing becomes deep and regular, awareness loses the sharp boundaries that separate one second from another. In such a state, external time continues normally, but subjective time opens wider. Minutes feel like hours, and yet the experience remains calm, not distorted. The brain's natural oscillations, patterns of electrical waves, align with the body's slower rhythms, mirroring the same synchronization that exists between celestial orbits and gravitational fields. Cultural and environmental conditions shape perception as well. In a city where movement, light and sound change rapidly, time feels fast. In open natural spaces, where little seems to happen, time feels slow. The difference lies not in the world, but in the number of signals processed. The human brain measures time by counting events. When those events decrease, the gaps between them expand in awareness. The same principle can be seen in outer space, where astronauts report a sense of timelessness. Without the regular alternation of day and night, or the familiar noises of Earth, their perception drifts, and the division between seconds and minutes becomes less defined. Psychologists often describe this experience as temporal dilation, a subjective version of the same principle that physics observes in motion and gravity. While relativity changes time's pace through speed and mass, perception changes it through focus and calm. Both rely on the same foundation, change. When change slows, time expands. When change accelerates, time contracts. The brain, like space-time itself, adjusts to the conditions around it, maintaining order even as its rhythm shifts. This understanding has practical consequences. When the body and mind are placed in a calm environment, dim light, soft sound, rhythmic breathing, the sense of time slows naturally. Meditation, slow walking, or listening to monotone sounds all produce this effect. It is not imagination. The body's systems coordinate at lower frequencies, and awareness synchronizes with them. Each heartbeat becomes a marker of time's passage, and as the heart slows, the seconds stretch. The quiet rhythm of the body becomes an internal equivalent of the universe's wider geometry, showing that perception and physics obey the same underlying principle. Time flows differently according to the frame of reference. This similarity reveals something profound about connection. The curvature of space-time and the calmness of the mind both create forms of stillness. They slow experience in proportion to balance. In one case, mass bends geometry. In the other, attention bends perception. The results, though vastly different in scale, are parallel. When awareness becomes steady, external time no longer feels fixed. It blends into the slow continuity of experience. The seconds lose their edges, merging into a steady current that carries thought gently forward. In everyday life, this capacity for temporal flexibility can restore equilibrium. The modern world moves quickly, filled with signals that accelerate the inner clock. Yet the ability to slow down remains intact, requiring only the deliberate act of noticing. The breath provides the simplest example. Each inhale and exhale defines an interval. By attending to it, awareness reconnects with a slower rhythm, one that the body has known since birth. The heartbeat, the rise and fall of the chest, the sound of wind or rain, all are clocks that remind the mind of the natural pace it once shared with the world. The perception of time, therefore, is not a flaw or illusion. It is an adaptation, a way for the organism to experience reality in useful segments. It can stretch for contemplation or contract for survival. It does not contradict physics. It complements it, filling the structure of space-time with personal meaning. When calmness returns, perception settles, matching the steady rhythm of the body to the slower rhythm of the universe. The listener who lies quietly now, hearing these words at a gentle pace, participates in that process. As awareness fades towards sleep, perception drifts further from measurement. The body remains on Earth, moving through gravity's curved field, while consciousness floats in a frame where time loses its boundaries. In that transition, the internal and external become indistinguishable. The slow physics of the universe and the calm mechanics of the mind merge into one continuous rhythm. This is the human perception of time, not a clock on the wall or a formula in a book, but a quiet experience of the same reality that governs the stars, the personal horizon of stillness. Every person carries a horizon within the mind, an invisible boundary that marks the limit of awareness, the edge where conscious thought begins to dissolve into quiet observation. It is not a wall or a place. It is the moment when attention slows enough to notice itself, when motion becomes stillness, and the ordinary sense of time begins to fade. This horizon functions in a way that mirrors the gravitational boundaries of the universe. Just as a black hole's event horizon defines the point where time stretches toward infinity, the personal horizon defines the point where the rhythm of thought stretches until it almost stops. What lies beyond it is not darkness or absence, but calm continuity. To reach this inner horizon, nothing needs to be forced. The mind, like the universe, obeys predictable rules. When external motion ceases and internal resistance lowers, awareness naturally draws inward. The breathing deepens. The heartbeat slows. Each sensation becomes part of a broader field of still perception. Thought, once active and scattered, begins to move in longer intervals, forming a single steady current. At this pace, time as a sequence of moments gives way to time as a field, one continuous present, without sharp divisions between before and after. This is not imagination or philosophy. It is the biological reflection of a physical truth. Systems slow when energy dissipates, and in that slowing, order emerges. The process resembles gravitational time dilation in a quiet psychological form. Near massive bodies, time stretches because the fabric of space-time bends inward. In consciousness, time stretches because the field of awareness bends inward. In both cases, motion continues, but it loses urgency. The seconds remain, but their meaning changes. The distinction between one and the next becomes softer. Each breath feels longer, each thought wider. The mind moves through a curved geometry of its own, where rest becomes the straightest possible path. At the personal horizon of stillness, sensory perception begins to loosen. External sounds grow distant as if they were happening in another layer of time. The mind no longer reacts quickly to stimuli. It registers them, but gently, allowing them to pass through. This reduction of reaction is not detachment, it is alignment. Awareness no longer resists the flow of time. It moves with it, following the curve instead of opposing it. The brain's activity, measurable through its slow electrical rhythms, mirrors this shift. High-frequency waves that once marked active thought give way to slower oscillations, each cycle lasting longer, each pause between cycles wider. At this horizon, memory and anticipation also change form. The mind no longer measures what has passed or predicts what is to come. It rests in a steady recognition of continuity. The present becomes elastic, able to stretch and accommodate both thought and silence without distinction. Time feels slower, not because it has changed, but because awareness has reached a point where measuring it no longer seems necessary. The seconds expand naturally, balanced by the stillness that now fills the space between them. If described from the outside, this state would seem like rest, but within it there is structure, the same geometry that governs the wider universe. The body remains bound by gravity, the lungs continue their rhythm, and the heart beats at intervals shaped by oxygen and pressure. Each system maintains order through cycles, and each cycle participates in a pattern larger than itself. The mind, now calm, observes this structure directly. It does not invent meaning. It simply notices the quiet synchrony between inner and outer worlds. This experience, does not separate the person from the universe. It reconnects them. The same equations that describe how space-time curves under gravity also describe how systems stabilize through balance. In both, stillness is not absence but symmetry, a condition where motion is distributed evenly, where energy flows without turbulence. The personal horizon is the psychological expression of that condition. It is the point at which internal gravity, the pull of attention, reaches equilibrium with external influence. Beyond that point, awareness no longer struggles to interpret. It simply exists, suspended in observation, timeless and steady. As this state deepens, thought and breath synchronize. Each inhale marks a gentle expansion, each exhale a soft contraction, mirroring the cosmic rhythm of galaxies drifting apart and slowly returning through gravity's pull. The pattern is endless but not repetitive. It continues without urgency. The body at rest participates in the same rhythm as the universe, a slow oscillation between movement and stillness. The sensation of time dissolves into that movement, and awareness becomes part of the same continuity that connects light, matter, and energy. In this horizon of stillness, there is no need to seek sleep or force relaxation. Both arrive naturally when awareness ceases to divide experience into moments. Just as light crossing the boundary of a black hole never escapes, thought crossing the boundary of deep rest never returns in the same way. It becomes part of the background, part of the field that sustains perception itself. The result is not unconsciousness, but quiet integration, the state in which body and mind operate without resistance, guided by the same smooth geometry that governs stars and space. The personal horizon of stillness is, therefore, both an inward and outward truth. In physics, it explains the behavior of time under gravity. In experience, it explains the behavior of thought under calm. Both reveal the same law: systems slow at the edge of depth. The deeper one goes, the slower time becomes, until there is no difference between motion and rest. This is not an ending, but a point of balance. The threshold where the individual rhythm merges with the universal rhythm, where time no longer feels measured, and the self becomes another expression of space-time's endless calm. The long pause of the universe. The universe is not in motion without rest. Beneath its expansion, its collisions, and its constant rearrangement of matter, there exists an equilibrium, a long pause woven through every process. This pause is not absence or silence. It is continuity. It is the moment between the heartbeat of galaxies, between the rise and fall of energy, between the unfolding of events so vast that they appear motionless when seen from far away. The pause of the universe is not empty. It is the stable background that allows change to occur without chaos. It is the balance that makes movement meaningful. If one could step outside the boundaries of motion and observe everything at once, the universe would appear perfectly still. Galaxies would hang in quiet spirals. Light would cross the void with steady patience. Particles would drift through fields shaped by gravity and energy, following invisible patterns. Every event would continue exactly as expected, with no sense of hurry or delay. From that distant perspective, the unfolding of cosmic time would look less like motion and more like structure, an intricate pattern of relationships held in a constant, unbroken balance. This stillness does not mean the absence of energy. On the contrary, it is the order of energy distributed according to the laws of physics. The expansion of space itself occurs without noise, at a rate so constant that it defines the rhythm of existence. Galaxies move apart, stars burn and cool, and black holes slowly evaporate, yet the total arrangement remains coherent. Entropy increases, yet the increase follows a predictable path. The universe pauses in its own way by maintaining this consistency, not freezing motion, but regulating it so that everything unfolds within limits that never break. When scientists look into deep space, the light they observe has traveled for billions of years. What they see is not the present, but the past, stretched and softened by distance. This light carries the record of ancient events, remnants of a time when the universe was younger and denser. Yet those photons arriving now preserve their rhythm perfectly. Their waves are longer, their frequencies slower, but their pattern remains unchanged. They show that time across cosmic distances does not vanish. It elongates. What began as motion ends as stillness in perception, and in that stillness, the universe reveals its quiet constancy. In this long pause, every object plays a role. The stars act as engines of energy conversion, transforming hydrogen into light that will travel until it fades into the background radiation that fills all of space. Planets orbit in silence, following curved paths defined by gravity's smooth geometry. Black holes hold matter in suspension, slowing time near their horizons until even seconds stretch into near eternity. On the largest scales, clusters of galaxies drift through expanding space, their motion too slow to notice within any human lifetime. Yet each movement, from the smallest atomic vibration to the grandest galactic drift, contributes to one continuous pattern, a rhythm so vast that it feels still. This sense of cosmic stillness is not a perception error, it is the natural result of scale. The distances and durations involved are beyond human experience. What seems unmoving is simply moving too slowly to perceive. The pause of the universe is the difference between our measure of time and its own. For us, seconds mark change. For it, change requires billions of years. Its heartbeat is the birth and death of stars, its breath the expansion of space. Compared to that, the human lifetime is a flicker, but the flicker is part of the whole, a brief expression of the same quiet law. The long pause is also present in the smallest phenomena. Inside atoms, particles vibrate according to precise frequencies, yet between those vibrations are infinitesimal moments of stillness. In those gaps, the universe rests before beginning again. The same is true of waves in light, of oscillations in energy, of the flow of heat between bodies. Every movement includes a return to equilibrium, however brief. This alternation between motion and rest, between expansion and compression, is universal. It defines the structure of time itself. Without pauses, time would have no meaning, because there would be no distinction between one moment and the next. The pause is what makes sequence possible. When the human mind becomes quiet enough, it can sense this same rhythm within itself. The slowing of thought mirrors the slowing of time in gravity. The widening of awareness mirrors the expansion of the universe. In calmness, perception aligns with the long pauses that fill the cosmos. Breathing becomes the measure of space. Stillness becomes the measure of time. The listener, resting now with awareness drifting and thoughts fading, is participating in that same universal pause. Nothing stops completely. yet nothing demands movement. Everything exists in balance, suspended, gentle, exact. Eventually, even the universe's motion will reach a deeper stillness. The stars will exhaust their fuel, the black holes will evaporate through faint radiation, and the expansion of space will stretch light until it fades into uniform darkness. Yet even then, equilibrium will remain. The particles that persist will continue to move slowly and evenly across a landscape of infinite calm. Time will not end. It will lose urgency. The cosmos will not disappear. It will rest. The long pause will become total, a state of balance so complete that change will cease to require effort. The listener's rest now echoes that future, the slowing of thought, the fading of awareness, the merging of perception with silence. All are reflections of the universe's own path toward stillness. In this way, to rest is to align with the natural rhythm of existence. The breath moving in and out is a small version of expansion and contraction. The slowing heartbeat is a reminder that gravity and time work together not only in the stars, but in the body itself. As the story closes, the voice becomes part of the pause. The words lose shape, blending with the silence between them. The mind floats in the same calm that governs the cosmos. The long pause of the universe continues, steady, endless, and whole. Time stretches gently forward, yet in its rhythm nothing feels like movement. It is the soundless balance that holds everything together. The listener rests within it, part of the same field, part of the same quiet eternity.